variances are equal. Do you want to try the gross one first, or you want to go for the easier one first? The gross one. Okay, so let's start with example 2. This might be easier if you do this and have them just sitting next to each other so you can have that formula right next to it. We're going to try doing this formula actually using our calculator just to make sure we can. And then we're going to, I'm going to show you how to use the program where your calculator will do it for you. I think that there will be very rarely an instance where you would need to do this calculation by hand, but if you do, we should be able to do it. Okay, so since this says, I'm looking at my flow chart now. Are both population standard deviations known? I did not write down the results below, so hold on. It says the costs for, is it sedans, that one? Okay, so they have that for the manufacturer, or we've got info for the competitor. The manufacturer we're going to call X bar 1. That is 52 cents per mile with a standard deviation of 5 cents per mile. And there are 30 in our sample size there. For their competitor, it's X bar 2 equals 55 cents per mile. And the second standard deviation is 7 cents per mile. And N sub 2 is 32. Okay. So, do we know the population standard deviation in this one? Where? Right, but S stands for sample standard deviation. Do you guys remember what the symbol is for population standard deviation? Sigma, so it's that O with the tail on it, right? And it actually does matter, the letters that they use implies it. So this is not going to be 8.1. We're going to keep going down the flow chart right here. Are both of the populations normal, or are the sample sizes at least 30? Yes, they're both at least 30. Are the population variances equal? It says here, assume the population variances are equal. And that is going to be in the question. So you never have to figure that out for yourself. Like on an AP test or anything, they'll always say whether they, and if they don't say, assume the population variances are equal, if it doesn't say at all, you assume that they aren't equal. Okay? All right. So let's start with H sub O and H sub A. Says the manufacturer claims that the mean operating cost per miles of its sedan is less than its leading competitor. So they're saying that their manufacturing time, no, operating cost per miles is less. This is their claim. Mu sub 1 is greater than or equal to mu sub 2. I'm assuming at this point, you guys tell me if I'm wrong, I'm assuming that you guys are pretty comfortable with writing null and alternative hypotheses at this point. Okay. All right, I'm going to draw a little bell curve. Left, right, or two-tailed? Left. Do you guys want to use rejection regions or p-values? They're both valid. Your call. Yeah. Okay, so let's try p-values this time. So we don't need to look up anything to find out what this line is. All we need to do is write down that alpha is 0.05. Actually, the only way to do p-values with a t-chart is by using your calculator, which we will use in a minute. So we're going to have to solve this two different ways, because if we use the formula, we have to use rejection regions for right now. Okay, so let's just quickly look up what this line would be as well. Grab your t-chart. This is a one tail. One tail at 5%. And we said that the variances are equal, so that means that our degree of freedom is adding together the two ends and subtracting 2. Which means we need to add 30 and 32 together and subtract 2 to get what? 60. So you're going to go down to 60 down here. And you're looking in that 5% one tail category. I get 1.671. You guys seeing the same thing I am? Okay. Make it negative 1.671. All right. Now we got this monster horrible formula to do. So we're going to start, and I'm not keeping this off camera, but I'm looking at my yellow section here that says variances are equal. Okay, and we're going to try this huge monster formula together. Okay, so x bar 1 minus x bar 2 on top. On the bottom, we're going to have 2 big square roots. On the top is n1, or n1 minus 1. Do you want me to show all my work, or do you want us to start skipping some steps here? Like, do you want me to write 30 minus 1, or just 29? Will you be able to follow it, or would you like it all laid out? Okay, let's lay it out. So 30 minus 1. For n sub 1 minus 1, and then I'm going to take that first sample standard deviation and square it, plus, and I'm going to take 32 minus 1 times 0.07 squared. Okay, on the bottom here is going to be n sub 1 plus n sub 2 minus 2, which is 30 plus 32 minus 2. Again, showing all my steps, times 1 over 30 plus 1 over 32 in a square root. Okay, now comes the hard part. How to put this in your calculator. So I'm going to put this up here, calculator beneath it so you can see what I'm doing. Okay, so on the top you're going to put in parentheses 0.52 minus 0.55 parentheses divided by. Now mine looks different than yours. Actually, let me make it not different. I have a calculator here I can use. Okay, so 0.52 minus 0.55 divided, second square root on the bottom. Actually, before the square root, put another parentheses. I'm not going to do all of these little tiny maths because I can do some of it in my head. Like, I know I wrote down 30 minus 1 here, but I'm going to write 29 in my calculator because I don't need my calculator to tell me what 30 minus 1 is. Times 0.05 squared. We actually need a parenthesis in front of this one too. You have to go back to that 2 and hit second insert and then a parenthesis. Plus 31 times 0.07 squared. And then that's our end of our first